Hello, Meteor.
Hello, Meteor.
Have you heard about the website called Discovery.com?
Discovery.com is my guidebook for life. I learned how to plant an herb garden, train my dog, and cure my dandruff.
I learned that most meteors burn up in Earth's atmosphere. Ah! The atmosphere! Ah!
The atmosphere! Ah!
Welcome to Short Planetary Geological Essays, narrated by Daniel Hutchinson. Saturn's moon Dione. Dione is a moon of Saturn. It was discovered by Italian astronomer Giovanni Cassini in 1684. At 697 miles in diameter, Dione is the 15th largest moon in the solar system and is more massive than all known moons smaller than itself combined. Dione's interior is a combination of silicate rock and water ice in nearly equal parts by mass. Dione has a 249-mile radius rocky core surrounded by a roughly 99-mile envelope of water, mainly in the form of water ice, but with the lowermost part of this envelope existing in the form of a liquid saltwater ocean. When the Voyager space probe obtained images of Dione in 1980, there was what appeared to be wispy features covering its trailing hemisphere. Voyager also found that Dione's leading hemisphere is heavily cratered and is uniformly bright. Its trailing hemisphere, however, contains a network of bright ice cliffs. The Cassini probe flyby of December 13, 2004 produced close-up images revealing that the wisps were bright ice cliffs created by tectonic fractures. Dione has been revealed as a world possessing enormous fractures on its trailing hemisphere, some of them several hundred feet high. Dione features linear surface features that are up to hundreds of miles long but less than 3 miles wide. These lines run parallel to the moon's equator and are only located at lower latitudes, at less than 45 degrees north or south. These linear surface features are brighter than everything around them and appear to overlay other features on Dione's surface, such as ridges and craters, indicating they are relatively young. These lines are of exogenic origin, the result of the emplacement of material across Dione's surface by low-velocity impacts of material, possibly a source from Saturn's rings, the other of Saturn's moons, and close-approaching comets. Dione's heavily cratered terrain has numerous craters greater than 62 miles in diameter. The plains areas have craters less than 19 miles in diameter, with some of these plains being more heavily cratered than others. Much of the heavily cratered terrain is located on Dione's trailing hemisphere, with the less cratered plains areas on its leading hemisphere. This suggests that during the solar system's heavy bombardment period, Dione was tidally locked to Saturn in an opposite orientation. With Dione being relatively small, an impact causing a 22-mile wide crater could have spun the satellite. Because there are many craters larger than 22 miles in diameter on Dione's surface, the moon could have been repeatedly spun during its early heavy bombardment. The current pattern of cratering and the bright albedo on Dione's surface of its leading side suggests that it has remained in its current orientation for several billion years. Compared with the craters seen on the Moon and Mercury, Dione's craters lack high relief features. This is due to slumping of the weak, icy crust over Dione's billions of years of existence. The Cassini space probe has provided planetary geologists with evidence that Dione is more active than previously thought. crustal depression associated with a prominent mountain ridge on Dione's leading hemisphere is best explained with there existing a global subsurface liquid ocean like that on Enceladus. Janiculum dorsa ridge on Dione has a height of 0.6 to 1.2 miles. Dione's crust seems to be warped by 0.3 miles underneath it. This suggests that the icy crust was warm when the Janiculum dorsa ridge formed, possibly due to the presence of a subsurface liquid ocean, which increases tidal flexing. I hope you've enjoyed watching this short planetary geological essay on Saturn's moon, Dione. Thank you for watching.